Password entropy is a measure of predictability of a computer password. The higher the entropy, the more difficult it is to guess the password. The relationship between the password entropy P measured in bits and the number of guesses G required to decode the password is given by this formula. Calculate the value of P for a password that takes 5,000 guesses to decode. 5,000 guesses means G equals 5,000. 0.321 P equals log base 10 of 5,000. Type the equation first. 0.321 P equals control 10 to the x power. Base is 10 of 5,000. Then control menu. Enter, enter, enter. P equals 11.5. 5b. Write down G as a function of P. We do know log base B of x equals C. Then you will put B as the base both sides. Then x equals B to the 6th power. We have 0.321 P equals log base 10 of G. Base is 10, so both sides I add 10 as base. G equals 10 to the 0.321 pth power. 5c. Find the number of guesses required to decode a password that has an entropy of 28 bits. Write your answer in the form of scientific notation. 0.321. This P equals 28, so we substitute 28 for P equals log base 10 of G. We put this into calculator. 0.321 times 28 equals control 10 to the x power. Base is 10 of G. Then control menu. Enter, enter, enter. 9.73 times 10 to the 8th power. Remember this E means 10 to the what power? You cannot write E8 on your paper. You won't get any credit for it. There is a point on the graph of a function G of P with the coordinates 0, 1. Explain what these coordinate values mean in the context of computer passwords. G of P is like f of x. So this 0 is x, 1 is y. For G of P function, this 0 equals P, G equals 1, P equals 0, G equals 1. P stands for entropy of the password. G means number of guesses. So when the entropy of the password is 0, one-time guess can decode this password. Question 6. The intensity level of sound L measured in decibels, dB, is a function of the sound intensity as watts per square meter. The intensity level is given by the following formula. L it's the intensity level of sound. This S is the sound intensity. An orchestra has a sound intensity of 6.4 times 10 to the negative third power. Calculate the intensity level L of the orchestra. L equals 10 log base 10 of sound intensity is S. So we plug in 6.4 times 10 to the negative third power times 10 to the 12th power. We will put this into calculator. 10 times control 10 to the x power, go to log. Base is 10. 6.4 times 10 to the negative third power, then times 10 to the 12th power. Enter. 98.1 as a 3-sig fix. So L equals 98.1 for B. Write down S as a function of L. L equals 10 log base 10 of S times 10 to the 12th power. First of all, you need to isolate the log. If I have a log base B of x equals C, we need to add base B both sides. So we get x equals B to the 6th power. First step, divided by 10, both sides. L over 10 equals log base 10 of S times 10 to the 12th power. Add base 10 both sides. Cancel S times 10 to the 12th power. Left side 10 to the L over 10th power. Then we divide it by 10 to the 12th power, both sides. We do know a to the mth power over a to the nth power equals a to the m minus nth power. So we got S equals 10 L over 10 minus 12th power. Let's go to C. A rock concert has an intensity level of 112 dB. Find the sound intensity S. L equals 112 dB. So we plug into this function. 112 equals 10 times log base 10 of S times 10 to the 12th power. By solver, type the equation into the calculator first. Control menu, enter, enter, enter. S equals 0.158. S equals 0.158. Question 7. Stars are classified by their brightness. The brightest star in the sky have a magnitude of 1. The magnitude m of another star can be modeled as a function of his brightness b, relative to a star of magnitude 1, as shown by the following equation. The star called a Cubans has a brightness of 0.0535. Find the magnitude of a Cubans. Brightness means B. We plug into this function. M of 0.0535 equals every single B turned into 0.0535. 1 minus 10 over 3 log base 10 of 0.0535. Go to calculator, 5.24. Let's go to B. Write down B as a function of M. Let's write down this formula first. M equals 1 minus 10 over 3 log base 10 of B. Remember that M of B equals 1 minus 10 over 3 log base 10 of B. This is a function form, just like f of x. The same as M equals 1 minus 10 over 3 log base 10 of B. First of all, we need to isolate the log.
Minus 1 both sides.
M minus 1 equals negative 10 over 3 log base 10 of B. We try to get rid of negative 10 over 3. We can times its reciprocal, negative 3 over 10. So both sides we times negative 3 over 10. Reduce. We got log base 10 of B equals negative 3 over 10 times M minus 1. Second step, if you got log base B of x equals C, we need to add base B both sides so that I can get x equals B to the 6th power. Base of log is 10, so we add 10 as the base. We got the B equals 10 to the negative 3 over 10 times M minus 1th power. This is the solution to B. Sirius has a magnitude of 7. It's the least bright star visible without magnification. Find the brightness of Sirius. We are given this M equals 7. Then we will do substitution for M. 7 equals 1 minus 10 over 3 log base 10 of B. Type the equation into this calculator. 7 equals 1 minus control divide 10 divided by 3 times control 10 to the x power. We got log base 10 of B. Control menu. Enter, enter, enter. B equals 0.0158. D. Find how many times brighter a Cubans is compared to Sirius. How many times means division. Compared to Sirius, this go to denominator. The brightness of a Cubans is 0.0535. Sirius, we just figured out 0.0158 equals 3.39.